Hi kids, welcome back. This is our ninth unit, the first one that is not going to be on the AP test. So we're going to do a lot of review for the AP test and we're going to slow down. Let's start with this problem. If you remember your chemistry, the answer is number 3, electron, because electrons are negative and the nucleus is positive. So that's an important topic for this next unit. Charge. More specifically, electric charge. Electric charge in physics is a lowercase q. It's measured in coulombs. Capital C. So the charge Q of an object could be 5 coulombs, 10 coulombs, or much more likely a millionth of a coulomb, a trillionth of a coulomb, some nanocoulombs. Okay. Have you guys ever seen Scotch magic tape? Hashtag sponsored. The magic thing about this magic tape is you stick it to the board and you rip it off real fast and you look closely and you'll see magic. Stick it there. Get it nice and stuck. And then rip it off. And if you hold it over here, you could, in theory, see the magic happen. The magic. There it goes. You see that? As I bring this piece of tape over to the one in my other hand, it kind of bends away due to why? Charge? No, magic. Okay, it was magic. So now we're something different. Have you guys ever heard this idea that pennies are so worthless? It costs the government more to make a penny than the value of the penny than 1 cent. It's true. Pennies are made of copper, which could be used for like wires, and zinc, which is also useful, I think. So it doesn't really make sense to have pennies. If I were president, I would do lots of things, but one of them would be to abolish pennies. No more pennies. Just take pennies and cross them right out. Yeah. Would this cause any problems? You might not realize what this would do. So let's look at another country that doesn't have this problem. In Vietnam, due to history and inflation and reasons, the one Vietnamese dong, or no, $1 is about 20,000 Vietnamese dong. Not that they're all like super poor in that country. Most people are millionaires, billionaires, but if the exchange rate is just very, very low. And for that reason, no one in Vietnam uses coins. They haven't been printed since 2003. The lowest bill in Vietnam is 200 dong, then 500, then 1,000. I went there like a few years ago, and I never saw any of these. The lowest ones I would ever see are 2,000 or 5,000, and prices would reflect that. If you're walking down the street and looking in all shops, or you look at a menu, a restaurant, you'll never see something that costs 10,005 dong. You'll never see anything like that because people don't have those bills. They don't exist. It's not physically possible to give someone 7 dong. Even 200, 500, the bills exist, but they're pretty rare. They almost are not used. Even the 1,000 is also very rare, especially I guess for like rich American tourists. They also basically don't exist. They actually do exist. You can find them, but they're not commonly exchanged in day-to-day life. So So, because the lowest denomination is basically 2,000 or 1,000 dong, prices reflect that. You will never see someone ask you for five VND. You'll never see a price listed as like 19,999. It'll just be 20,000. That's because the lowest quantities don't exist. If I get rid of pennies because I was president, the same thing would happen. You couldn't see a sign on the street that said, "Ooh, fresh pizza, 99 cents," and go in and give the person $1 and get a pizza and then say, "Hey, where's my change?" That wouldn't work because there's no pennies anymore. They literally don't exist. So you couldn't charge 99 cents. That amount of money just wouldn't make sense anymore. This is a really weird analogy, but assume that the US is like the normal system. Obviously a very Western centric view, but we are American, so it kind of works out. So the US uses dollars. Dollars are the normal amount. A dollar is an average amount of money. Again, not really very like cosmopolitan to say that, but it works with this analogy. A dollar is a very normal amount of money. A VND, a dong, is a very, very small amount of money. A coulomb is a unit of charge. A coulomb is a massive, humongous, gigantic amount of charge. What has a lot of charge? If I have like a lightning bolt, that probably only has like 15 coulombs, which is a huge amount of charge. If you touch a lightning bolt, you'll figure it out pretty fast. This is a massive amount of charge. This is like more charge than you could need to power your house or kill like a million cows or very silly, or like reanimate 100 Frankenstein monsters. I don't. It's a lot of charge. If I were to like comb my hair, if I comb my hair and I touch the comb like this, I hear a little bit of like a little crackle. That's not a full coulomb. That's much, much less. That's probably like nano coulombs or pico coulombs. It's way less. Oh god, my hair messed up. Oh no, my reflection. Oh, it's fine. So you'll very often see in problems in physics nanocoulombs, picocoulombs, maybe even femtocoulombs, because a coulomb is so very large that no one ever uses that. So this is a weird question. In Vietnam, certain amounts of money, they just don't, like, you never get charged that amount. If I go to a store and I get a nice banh mi and a nice iced coffee, they might say, oh, 30,000 dong, or 32,000, or 34,000, or 36,000. But they never say 35,700. In the US, you never get charged like a fraction of a penny. If you go to McDonald's and get like a soda for $1, it comes out to $8.875 due to sales tax. But they don't charge you 8.875, they charge you $1.09. If I got rid of pennies, they couldn't do that. They charge you $1.10. So $1.09, $1.09 is not possible. $1.08 and 0.875 cents is not possible. Some values of money are not possible. Are any values of charge not possible? What do you think? Some values of charge are not possible. There was a very famous experiment by a guy named Millikan. You don't really know much about him, but basically, he measured the charge on very small oil droplets, and he found out what I just told you. Not every value is possible. Some values are just never going to happen. some objects can have a charge of 0. In fact, that's actually very common. Most objects in your life have no charge. If you touch like a marker or like a little like magnet or a comb or like a mouse or whatever, you don't really get shocked. You don't really feel any charge. Almost everything in life is neutral. But if I comb my hair or like I put on a sweater or like I rub a balloon on like a rabbit, for some reason, I could get a charge. The charges always fit this equation. When Millikan measured the charge on all the oil droplets, he didn't get any number he wanted. He would always get n times e. N is in integer. It could be positive or negative, but it's got to be like a whole number, not a decimal, not a fraction. And e, it was 1.6 times 10 to the negative 19th coulombs. A very, very small charge, but a specific value. So he measured one oil drop and it came out to negative 3.2 times 10 to negative 19th coulombs. Then he measured another one and it was a little bit more negative. It was negative 4.8 times 10 to negative 19th coulombs. I'll tell you this, he did the experiment a lot of times. He never found a single oil drop that was negative 4.0 times 10 to negative 19 coulombs, or 4.1, or 4.2, or 3.3, or 3.5 times 10 to negative 19 coulombs. All those values between these two are physically impossible. Can you explain why? Wow, great explanation. But I'll tell you my way too. When I ripped the tape off the whiteboard, a little bit of glue was left behind. And this is something like the big 3M, big tape companies don't want you to know. Tape glue is made of electrons. So when I stuck the tape on and I ripped it off really fast, a little bit of glue was left over. That's electrons. That left the tape missing electrons. The tape was neutral. It lost electrons. It became positive, and that's why the two positive tapes repelled when I did that thing with the camera, and you definitely saw they definitely repelled. Yeah. How many electrons were left on the wall? When I rip off the tape and the glue's left behind, the glue might have one electron. If it did, the glue's charge would be negative 1.6 times 10 to the negative 19 coulombs. If the glue had two electrons, this would be the charge of the glue. If the glue had three electrons, this would be the charge of the glue. But how can the glue have a charge of 4.0 times 10 to the negative 19 coulombs? That would have to mean that the glue had between 2 and 3 electrons, like 2.5 electrons. That's not possible. You can't split an electron. They're only in whole integer values. So that's why some charges are just not possible. Just like some prices and like dollar amounts are just not possible. Because the smallest denomination can't break up into that value. Usually we have a massive charge, so that almost never comes up in real life. But it is technically true that you can't have some charges due to the charge of an electron. So it comes out nicely. This E is the elementary charge. Thankfully, protons and neutrons have the same magnitude of charge. One's positive, one's negative. So QP, that's for a proton, is plus 1.6 times 10 to the negative 19 coulombs. QE for an electron is minus 1.6 times 10 to the negative 19th coulombs. You should probably know this already. Qn for a neutron is neutral, 0 coulombs. So, all charges are based on the charge of all the protons and neutrons in the object. My marker right here is neutral, not because it has no protons and no electrons, because it has an equal number of protons and electrons. If I comb my hair very vigorously, my hair will become a little positive and my comb will be a little negative. Look at my comb. My comb is negative. That doesn't mean it has no protons, only electrons. It has a little bit more electrons than protons. And the number of electrons minus number of protons times this times -1, that would be the charge of the comb. So I guess it'd be like number of protons minus number of electrons. Yeah. Protons minus electrons times E is the charge on the object. This is not really relevant. I think it's on the equation sheet, but this will come up in a few practice problems, so you might want to write it down. The mass of an electron is this, and a proton and neutron are the same as each other, much more than this. I think it's like 1.67 10 to the negative 27th. You can correct me if I'm wrong. I'm not going to be offended. But those are some nice values. That's pretty much it. Just this idea, the charge is always some integer times its value. It's based on a whole number of protons and a whole number of electrons. This means charge is quantized. Quantized. Think of a quantity you can count. Charge is based on a number of electrons and protons, and they're both integers. You cannot have a fraction of a proton or a fraction of an electron. Charge is quantized. Money is quantized too. You can't have a half a cent. They don't make those anymore. You can only have a whole number of dollars and a whole number of cents. If you are going to get charged like half a cent because of tax and discounts and other weird stuff like some coupons, they're just going to round it to the nearest cent because money is quantized. You can only have specific values. Yeah, that's all I got for today. Hopefully this works. See you in class.